concept a day will make your F go away. Hi class, let's analyze on the first question, which is year STPM 2019. Now in STPM 2019, the question that came out wanted us to test about our particular concept in semester 3. Okay, so the question is, which statement is not true? Okay, is not true about damped oscillation. So damped oscillation. Now the question is, what is a damped oscillation? Okay, so either you know or you don't know. Okay, let's get to know then, if you don't know. Before we go to the damped oscillation, let's know about oscillation first. Now, oscillation, there are three types of oscillation. How many types? Three types of oscillation. And they are, okay, they are damped oscillation, free oscillation, and forced oscillation. Okay. Now, what is damped oscillation means? Is an oscillation where the amplitude of the oscillation decreases. Okay, so in a damped situation or in a damped oscillation, the amplitude of the oscillation decreases and loss of energy, and the system finally stops. So this is a basic and general definition of damped oscillation. Okay, now damped oscillation also got three types. Okay, they are called as under damping, also known as light damping, critical damping, and over damping. Okay, now let's look on to the next one, which is a free oscillation. Now free oscillation are oscillation which is undisturbed by external force and vibrate at its natural frequency. So the one that is highlighted are key points, keywords. So teacher want you to memorize the keywords. Okay. Okay. The next one is forced oscillation. Forced oscillation is the oscillation produced by a periodic external force known as the driving force. So you see the difference here is, forced oscillation got force. Okay, free oscillation is undisturbed by a external force. Okay, so can you see or not the difference between free oscillation and forced oscillation? Okay, all right. So let's move on to the next one and let's focus on the three types of damped oscillation. Under damping oscillation, okay, under damping oscillation, or we call it as light damping. That means very minimum of damping. So usually damping is associated with medium lah, usually, okay. So under damping, what is the keyword? The keyword is the amplitude of the oscillation decreases exponentially with time. Keyword number 1. Okay, so if you see in this diagram, okay, let me see here, okay. If you see in this diagram, you will notice that the amplitude at x equals to 0 is A naught, and then you realize that the amplitude decreases. Amplitude decreases. How it decreases? Decreases what? Exponentially with time. Okay, it decreases exponentially with time. Okay, now the second keyword is the energy of the system also decreases exponentially with time. So these are the two keywords for under damping, which you have to memorize. And then you have to also memorize the pattern of the graph for under damping, or we also call it as light damping. This is x, which is displacement, versus time. So we have an amplitude here because amplitude is also referred to as displacement. Okay. Now let's move on to the next one. Okay, there are three types of damp oscillation, right? So we already covered for under damping. So now let's look on for the next one, which is critical. Okay, critical damping. So the key words for critical damping is the system comes to stop in a very short time. Okay, so if you see in this graph, you will notice as the oscillation start, then you will realize that it comes to stop in a very short time. So you see here the time here. So I'm going to just draw the time here. So this is a very short time. Okay, and the next keyword is it return as quickly as possible to its equilibrium position. Okay, because of its system comes to stop in a short time, so it return as quickly as possible to its equilibrium position. So if you look at this graph here, you will notice that this is considered as equilibrium position. Okay, this line here. Alright. Okay, the next keyword is critical damping. Okay, damping is sufficient to prevent oscillation. So you know what is oscillation? Oscillation is to and fro motion. So you realize in this graph that there is no to and fro motion. Okay, so let's move on to the next one, which is an over damping. Okay, class. Now let's look at over damping. Okay, so the key word for over damping is the resistance of the motion is so large that actually the system takes a very long time to return to its equilibrium. Okay, so if you see in this graph, you will notice that the system takes a very long time to reach to zero. So here the over damping will be the one which is the red color here. Okay, so why did I put a tree graph here? So for you to differentiate between over damping, light damping, and also critical damping. So can you figure out which of this line is a critical damping? Okay, so critical damping will be this green light. Okay, and light damping, it will be this blue light. Okay, this blue line. Okay, not light, line. And then the green one is critical damping. So over damping will be this red line. Okay, so that's why you see it takes a very long time to reach to its equilibrium. Okay, because why? The resistance of motion is so large. Okay, let's come back to this question in STPM 2009. Which statement is not true about damped oscillation? Okay, choices of answer. In all damped oscillation, some of the mechanical energy is lost as heat. Now, if you refer back into our concept before this, you should have known the meaning of damped oscillation. Where damped oscillation are oscillation where the amplitude of the oscillation decreases and loss of energy and the system finally stop. So there is a what? There is a loss of energy in all damped oscillation. Correct? This is a general meaning of damped oscillation. So A is correct. Okay, so let's look at B. The B says in an overdamped, okay, in an overdamped oscillation, the object oscillate for a very long period. Okay, now that looks like as if it is right, but let's check on the concept. Now the concept says overdamping. Overdamped oscillation means overdamping. So the system takes a very long time to return to its equilibrium. So that is correct based on concept. Okay, let's look on our answer choice C. Under damped oscillation, the object moves to the equilibrium position in the shortest possible time and stop. That is not true. Okay, why? Okay, that's not true. Why? Because in and under damping, the amplitude of the oscillation decreases exponentially with time. The energy of the system also decreases exponentially with time. That means this is untrue. Okay, this statement here, okay, actually should be referred to critical damping. Agree? Okay, now let's look on the next one. Okay, in a critical damped oscillation, alright, in a critical damped oscillation system, the object moves to the equilibrium position in the shortest possible time and stop, which is true because if you look at your notes, you will realize that the system comes to a stop in a short time and return as quickly as possible to its equilibrium position. So what will the answer be? The answer will be C, because it asks for not true. Okay, now let's go on to the next question. STPM 2016. Okay, an oscillating spring mass. Oscillating means it goes through and fro. It's oscillating. Okay, is under damped. Which graph shows the variation of the displacement with time for the motion? Okay, displacement with time. So let's look at number A. Okay, let's look at the choices of answer for A. So A, if you see the amplitude is not, doesn't make difference here. Correct or not? The amplitude is the same. The amplitude here, okay, because amplitude is displacement, maximum displacement, right? So here is same and here also same. Okay, let me point this out here. Macam ni, same kan? So that means this is a free oscillation. Why free? Because it says oscillation is undisturbed by external force and it vibrates at its natural frequency. Okay, so A cannot be the answer. A cannot be the answer. Okay, now let's look at B. If you look at B, you will notice the amplitude first was at this position. After some time, the amplitude is in this position. Okay, that means amplitude is from here to here lah. So it's like, here. Okay, so amplitude decreases. As the time goes by, okay, as the time increases, amplitude decreases. So this must be definitely a damped oscillation. Okay, okay, and if it's a damped oscillation, then it's what is a under damping oscillation, because under damping oscillation means the amplitude decreases, okay, exponentially with time. Okay, now let's look at C. What's wrong with C? Okay, at C, if you realize that uh, this is the amplitude, okay, and then which is this is the amplitude, and then it takes a very long time for the system to come to equilibrium. Okay, so if it comes to equilibrium, it has to reach here, right? But it takes a very long time, so that means this must be an over damping. Okay, and then if you look at D, this is completely not even an oscillation. If it's an oscillation, it has to come like that, it has to go up and it has to come down, but this one tak ada langsung. So this is definitely, it's a critical damping. Now let's look on to the next concept. The next concept, let's look at this question and analyze. Okay, now an external force is applied to a damped oscillatory system so that the system could oscillate continuously. Hence, to maintain the maximum amplitude of oscillation, the frequency of the applied force is, okay, now you know this is a forced oscillation, correct? How do you know it's a forced oscillation? Because it says an external force is applied. Okay, the keyword says what? An external force is applied. Okay, but what does this external force has got to do with the frequency of the applied force? Okay, and what has that got to do with the maximum amplitude? So let's now discuss the next concept. This concept came out in STPM 2018. Okay, before we go forward, now let's look at what we understand with the word forced oscillation. Now the concept, if you want to go more deeper, force oscillation is oscillation produced by a periodic external force. Okay, this periodic means continuously you give the force. Now that's why it also being called as the driving force. Driving force means continuously you give the force. And why is it called as external? Why is it called as external? External means the forces are from outside the system. Okay, now that is what it means by force oscillation. Concept number one. Concept number two, the book says the frequency of the force oscillation is equal to the frequency of the driving force. That means the frequency of the continuous force. The frequency of the force oscillation is equal to the frequency of the continuously force. Okay. Next, the amplitude of a force oscillation varies with external driving force. That means by giving continuously this external force, it will change. That means it will vary the amplitude of the forced oscillation. Okay, so these are concept. Now we want to do application. Okay, let's look on to the next one. Now, if you look at this diagram here, we have this pendulum here. Okay, this is a pendulum here. Okay, when I change the color so it become a bit bright. This is the pendulum here. This is also called as Barton's pendulum. B-A-R-T-O-N pendulum. Okay. Now, in this pendulum, we have a pendulum X. We have pendulum A, B, C, D, E and F. Okay. Now, what's the difference between all this pendulum A, B, C, D, E, F? You will notice like the mass is similar, but the length are different, correct? Okay, now let's study about this pendulum based on the concept of forced oscillation. Okay, when pendulum X oscillate, okay, when pendulum X oscillate, okay, when you oscillate pendulum X, that means this pendulum will oscillate. Okay, that means it will through and fro motion lah. Okay, it will uh, oscillate like that lah. Okay, oscillate. Okay, the other pendulum are forced to oscillate. So when X is oscillating, this all pendulum will be forced to oscillate. Okay, now they are forced to what? To oscillate. Okay, now pendulum X, okay, pendulum X is known as the driver pendulum. Okay, a driver pendulum. Okay, this X is known as the driver pendulum. Pendulum A, B, C, D, E, F are known as the driven pendulum. Okay, that means they are forced to oscillate because of the pendulum X. That's why it's called as driven pendulum. Pendulum A, B, C, D, E, F are the one that undergoes forced oscillation. So if you look at this example, you will notice that when X is oscillating, it will force A, B, C, D, E, F also to oscillate. Okay, because of this string here. Alright, so what can we say? We can say A, B, C, D, E, F are or undergoes forced oscillation. Okay, now the concept. Okay, let's look at the concept. Let's connect this with the physics concept. Now, the concept says the amplitude of the forced oscillation. Okay, so let's see here. The amplitude of what? The amplitude of the forced oscillation. Who is going through forced oscillation? A, B, C, D, E, F is the one that goes through forced oscillation. So the concept says this amplitude of the forced oscillation is maximum when the driving frequency. Okay, who is driving frequency? Okay, let's look at who is driving frequency. Driving frequency is the frequency that is being of the X. Okay, is the frequency of the X, because X is the one that is the driver pendulum. Okay, equals. Okay, equals the natural frequency of the driven pendulum. Okay, so it says that the concept says that the driving frequency equals to the natural frequency of the driven pendulum, then the amplitude of the force oscillation is maximum. That means, what does it mean in a very simple English? If the frequency of fx is same as any of this frequency of this pendulum, then that particular pendulum will vibrate at a maximum amplitude. Okay, so in other words, the amplitude of the pendulum D is maximum when the frequency of oscillation of pendulum X is equals to the natural frequency of pendulum D. Okay, all right. So for the next concept is resonance is said to occur. Okay, so when we talk about resonance, we say resonance is said to occur when the amplitude of the force oscillation is maximum. So there's another thing you have to add in inside here. When the amplitude is maximum, what happens? The resonance is said to occur. Another concept here. Okay, all right. So in other words, what can I say? In other words, I can say the condition for resonance is the driving frequency is equal to the natural frequency of the driven system. Okay, all right. Now let's move on to the next slide. So now the question comes that since we have so many driven pendulum, so which driven pendulum will oscillate with maximum amplitude? Okay, let's look at this concept. The amplitude of the force oscillation is maximum when the driving frequency equals the natural frequency of the driven pendulum. This is a pendulum, correct? And then the frequency of a pendulum is such. So the frequency of a pendulum is related to its length. Okay, so if you look at all this, so length matters. So the one x which has the same length with x will be the driven pendulum, which is the D. So therefore pendulum D will oscillate with the largest amplitude. Okay, after knowing the concept, let's go back to the question. An external force is applied to a damped oscillatory system so that the system could oscillate continuously. Hence, to maintain the maximum amplitude of oscillation, the frequency of the applied force must be equal to the natural frequency of the oscillatory system. So the answer will be C. Right. The question is, state whether it is possible for damped oscillation to occur while a system is in resonant condition. So this is 2 marks. This question came out in STPM 2015. Now, before we answer this question, if you realize that they ask you first, is state whether it is possible. 1 mark. For damped oscillation to occur while system is in resonant condition. Explanation, another 1 mark. So now go back to the concept. We know that a system which is at resonant has to have a maximum amplitude and should be constant at resonant, correct? And we also know that for damped oscillation that the amplitude decreases over time. So is it possible? Definitely it is not possible to achieve a maximum amplitude when there is a damping. Okay? Why? Because system which is at resonance has to have maximum amplitude, whereas amplitude of the damping oscillation decrease over time.